Yeah, good afternoon, everybody. My co-host, Dr. Alexandros, panelists, and those participants who are online with us, following us with us. So the session for today is the primary and secondary resources, climate change aspects. So just as a small introduction, climate change is real and is happening. 85% of the world population is already suffering. 2 months ago, the Intergovernmental Panel on Climate Change released a deeply alarming report. It shows that climate disruption caused by human activities is widespread and intensifying. According to the report, it is unequivocal that human influence has warmed the atmosphere, ocean, and land. The report indeed is the code red for humanity. Coupled with the data impacts of climate change is the unsustainable consumption and production pattern. Humanity is putting the planet Earth under enormous pressure, fast depleting the Earth's natural resources. Consequently, the Earth overshoot day is every year is coming earlier each year. It has been projected that if the rest of the world were to consume like industrialized and developed countries, we would need an equivalent of 4 extra planets to satisfy such consumption pattern. Adding salt to this injury is yet another global challenge: plastic pollution. Around the world, 1 billion plastic drinking bottles are purchased every minute, while 5 trillion single-use plastic bags are used worldwide every year. A large amount of this plastic, unfortunately, ends up in our watercourses, forests, parks, damaging marine life, affecting our terrestrial environment and its wildlife. In view of these daunting challenges, the world has no other option than to double its effort towards restoring the world's ecosystem, biodiversity, forests, wildlife population, improve farming practices, reducing food waste, develop green technologies, cut down our carbon footprint, and rid the world from plastic pollution. Indeed, our policies, strategies, action plans, and reflection should be geared towards circular economy, sustainable consumption and production, nature-based solutions, low-carbon economy, and measures to increase our resilience with a view to recover from the COVID pandemic and to achieve the ambitious SDGs. As such, we have high hopes that the COP26 will take much bolder decisions for climate actions to maintain international peace and security and eventually ensure the survival of mankind. So in these few words, I now have the pleasure to introduce, we have 5 speakers. Dr. Ryu Koide1. He is a researcher at the National Institute for Environmental Studies, Japan, and his topic of discussion would be climate change mitigation, potential from circular economic strategies, a systematic review of consumer-oriented product service system. Second presenter will be Dr. Sho. He is already with us. He is also a researcher at the National Institute for Environmental Studies and of the University of Tokyo, Japan. His topic of discussion presentation will be on revealing carbon-intensive material footprints, including fixed capital effects. The third presenter will be Dr. Thelma Arco. She is an officer at the United Nations University Institute for Natural Resources in Africa and professor of the University of Ghana. Her presentation will be on low carbon technology and the 4th industrial revolution opportunities for Africa. Our 4th presenter will be Hiram Toira. I hope I have pronounced it correctly. I'm sorry if I haven't pronounced the name correctly. He is a student of industrial engineering studying at INTEC University and currently working as an industrial engineering technician at the INTEC My Peace Center. So his presentation will be on life cycle analysis of lyophilized fruit snacks production in the Dominican company Our Flavor. And the last presentation will be Dr. Mohit Arora. He is a researcher and associate at the Institute for Infrastructure and Environment of the University of Edinburgh. And his presentation will be on biological methods to increase housing resilience to flooding. Panelists, a very warm welcome to all of you. So just let me tell you that you have only 5 minutes of presentation. Each will have 5 minutes of presentation. We will take the questions after all the presenters, after the 5 presentations. Then we will have discussions. And after that, there will be a voting. Okay, so let's have the second presentation. It's Dr. Hata Sho. So the floor is yours.
Yep.
And your time starts now.
Okay, thank you, Chair, for introducing me. I'm Sho Hata from Japan. So let me start my presentation. Okay, please move on next slide. Okay, first, this slide shows the overview of this study. Material footprint is a consumption-based indicator, which is used to clarify who is causing the resource consumption. This indicator can reveal not only direct, but also indirect resource consumption of household, private company, capital formation, and so on. As you may know, resource consumption accounts for more than half of the climate change impact. Therefore, resource management is also essential for climate change targets. In this research, we established a new indicator, capital embodied material footprint. This indicator, CEMF, is a material footprint that includes the resources invested in capital formation required to accompany a given demand. For example, the footprint resulting from the supply chain for building restaurants is allocated to the demand for eating out, as shown here. In addition, as equation on the right side shows, we additively decomposed the material footprint of the fixed capital supply chain from production supply chain. So this was hidden in conventional material footprint. Furthermore, we define carbon intensity, the carbon footprint divided by the material footprint, as one simple indicator to connect material consumption and carbon emission. Please move on next slide. So let me move on next result section. So this result one shows capital embodied material footprint induced by household consumption in Japan. Left side shows CEMF via fixed capital supply chain, and the right side shows production supply chain. The color of the bar graphs indicate the type of resources as listed here. Of course, production supply chain is material intensive and carbon intensive. However, according to the table of fixed capital, the material footprint is equal to half of the volume of production supply chain, and the consumption of fossil fuels is less than a production supply chain, but much wood and iron ores are consumed here. So by these material footprints, via fixed capital emits a carbon footprint equivalent to 20% of production supply chain. Okay, please move on next slide. Okay, this bar graph demonstrates which fixed capital supply chain uses the material footprint, and the color of the graph shows the magnitude of the carbon intensity. The most material intensive supply chain is the fixed capital for service sector. About 120 megaton material footprint is induced via this supply chain. In addition, capital for service has also high-level carbon intensity. So service sector has an important role for the material management of fixed capital. Furthermore, capital for manufacturing and agriculture have highest carbon intensity. Therefore, they have large reduction potential of carbon emission to supply chain resource management. On the other hand, although the current footprint is small, we need to keep a close eye on the capital that will be invested in the future, such as renewable energy. We must manage the capital supply chain, especially low carbon technologies or green technologies, which will increase in the future. Please, next slide. Okay, please move on. Okay, so these are discussion points of this study. First, we have to consider about decoupling and mitigation of the capital-induced material footprint. For this, refrain the additional formation of fixed capital and conserve materials by improving the methods of fixed capital formation are important. Second is synergies of material footprint management with decarbonization targets. So if we neglect the fixed capital supply chain, achieving carbon neutral will be difficult because of the material footprint and carbon footprint via fixed capital. Third, towards a practical approach, we should apply material efficiency strategy or circular economy strategy to fix the capital supply chain. And we have to design management indicators and calculation guidelines like GHG protocol. Lastly, this material management is a common challenge for both developed and developing countries. That's all. Thank you for listening.
Yeah, so our next presentation will be by Dr. Tilma Arco. So the floor is yours, Dr. Tilma.
So thank you very much, Chair, for introducing me. I'm presenting on green energy minerals and Africa's development. Now, the climate emergency is actually driving a drastic shift away from fossils to renewables. And this transition is threatening a missed opportunity for many fossil-rich African countries who are very dependent on these resources to support their economy. However, many of these countries are also richly endowed in minerals and metals, many of which are being increasingly demanded for the production of these low carbon and digital technologies. And this opens up enormous market opportunities for Africa. Now, the rapid advancement in low carbon and digital technologies is increasing the usefulness of many elements. Currently, 69 elements of the periodic table are found useful for these technologies, and 58 are listed as traded commodities. Africa is endowed with 48 of these 58 elements, and currently Africa is among the top producer of 12 of these elements, and also holds large reserves of many of these minerals and metals. And these minerals and metals are widely distributed across 40 of the 54 African countries. Now, we all know about cobalt in DRC, we know about the platinum group metals in South Africa, the rare earth metals in South Africa, but beyond these, we want to look at a few of the other resource potential of Africa that are relevant for low carbon and digital technology. So we look at beryllium, which is useful in fiber optic cables and in cell phones and solar cells. Beyond United States, Brazil, and China, most of the beryllium resources are found in Africa. And in 2019, production volumes were recorded in Nigeria, Uganda, Mozambique, and Zambia. Now, graphite is also a rich resource in Africa, which is very important in the manufacture of batteries. And we have rich resources of graphite in Madagascar, Tanzania, Namibia, and Zambia. And in 2019, Mozambique was the third global producer of graphite. Now, with lithium, the continent of Africa is richly dispersed with a lot of lithium resources in Mali, Ghana, Congo, Namibia, and Zambia. However, only 2% of lithium production is currently taking place on the continent, even though the pegmatite rocks of the continent actually offers promise for more lithium discoveries on the continent. Now, with rubidium also, which is needed for solar cells and batteries, Africa, that's in Namibia and Zambia alone, hold over 80% of the country's rubidium resources. Now, what are the opportunities this has for us in the growing mineral value chain? Now, the narrow geographical focus of most production of these elements is a security concern. It's a supply security concern.
1 minute left.
particularly to the EU, to be able to deliver its Green Deal. But Africa has 16 of these listed critical raw materials. And that is an enormous opportunity for Africa to engage more widely beyond just mining of these minerals, but actually in higher levels of the mineral value chain. What are the policy considerations? Now, the full extent of the mineral potential of Africa is still not fully known. And so there's the need for increased investment in mineral mapping and exploration. And also there is a need for decarbonizing our industrial sector and by increasing research and development in green hydrogen, which can provide the base load to power green mining in Africa. And also the health and environmental impact of these minerals is not fully known. And so for Africa to contribute meaningfully to the mining of these minerals, it should also contribute effort to fill this current knowledge gap. These are the key references that used for this study. Thank you very much.
Okay, so our next presentation will be by Hiram Toirak.
Hello, can you hear me?
Yes.
Yes.
Hiram Toirak is not here. I'm his teammate. I will be presenting for him. Okay. I'm going to be presenting life cycle analysis of lyophilized fruit snacks and production in the Dominican Republic, specifically the company or flavor, which I'm part of. Can you pass the next slide, please? So in Latin America, we lost around $200 billion in potential exportation sales and production from fruits and vegetables. We can lose up to 40% of our production. Next, please. In the Dominican Republic alone, the country in which we live, we lost around 75,000 tons a year, equal to more than $50 million in potential exportation sales. Next, please. The main reasons are aesthetic standards, shipping and refrigeration, supermarkets, consumers, and others, which basically amount to infrastructure. This type of food waste, if we were to see it as a country, food waste would be the third largest contributor to greenhouse gases in the world. So we decided to take a case study for a company that reduces food waste. Next, please. That would be our flavor. The aim of this company is to take those foods that would otherwise go to waste and process them, creating freeze-dried snacks and products. Next, please. The system boundary of the company, basically a diagram that shows how it works, is we have two main inputs, the raw materials, aka the fruits, and the packaging. Those are processed, basically washed first with water. Then we have the electricity, which basically is the process of dehydration for the fruits. And finally, the fuel for distribution. That would be the packaging of the final products. The outputs would be the products and the food waste generated by basically cutting out the fruits, and the water waste generated by taking out the water. Next, please. We decided to use CIMA Pro. It's a computer program that evaluates the environmental impact of companies on the environment. We have, as you can see here, the variables like, for example, global warming, toxicity, water consumption, etc. And then the ones that we can control in the company. For example, how many fruits we harvest, the electricity, the packaging, all that. And assigns a numerical number of impact for those kinds of variables. Next, please. Those were the results where we finally assign an environmental impact on the environmental categories. Next, please. What we discover is very interesting. The company, as it promotes itself, is good for the environment. As we reduce food waste, water waste by our production. But what we discovered is very interesting, is that just by making very small changes, for example, solar panels, we can reduce all the other categories as well, which basically shows that by using life cycle analysis, we can not only understand how our companies affect the environment, but we can make small determined choices that can create a whole big impact on the company, like solar panels. Just by adding that small variable, we can reduce across the board all these variables. Next, please. So in conclusion, life cycle analysis allowed us to identify areas of improvement and possible solutions in very specific areas. Food waste is one of the biggest factors when it comes to damaging the environment, as we can provide proof by using CIMA Pro and also through our research. A company that says freeze-dried fruit in the way we design it, basically by taking the unsold fruits, has a very positive impact on the environment. Freeze-dry appears to be a very sustainable method of processing food as well as reducing it, again, based on the system that we designed with the program. Additional systems of water waste and reutilization for solar panels can create elevated positive impact in the future. Basically, take those variables, use the program, and see if we can generate big impact by just small changes. And the primary cause of freeze-dry is electricity. So companies that basically go for solar panels can reduce their whole operations, not only in cost, but also in environmental impact. Thank you. Those are our sustainable development goals that basically we would achieve by using the POST program. Thank you.
Excellent, Jose. So we are moving to the final fifth presentation by Dr. Mohit Vanura. He's with us.
Yes, hello everyone. Can you, do you have my slides? Great,
I think
yes. Thank you very much. So hello everyone, I'm Mohit. I'm a postdoc at University of Edinburgh, and I'll be talking about our research project that we are undertaking in Northern Ghana currently. Next slide, please. So global housing requirements, I think this is one of the biggest concerns from natural resources requirement perspective and also from financial perspective. You will see on the right side of the slides, that's the situation of low-cost earth-based construction in Northern Ghana. This is very similar to a lot of Asian African countries where people mostly come up with low-cost alternates to live their daily lives. But the challenges have been aggravated by the climate as we see more and more flood destroying these homes. In Northern Ghana itself, over 6,000 homes were destroyed last year. If you look at the country itself, over 2 million housing deficit. This is very common in developing countries across Africa and Asia. Now, circular economy and nature-based materials can actually help deal with this challenge at a lower cost and low emissions. And in this project, we want to find out what is the availability of those local resources and what is the engineering performance in providing structural and mechanical performance to deal with the flood resilience in flood season. Next, please. For this study, we have chosen two regions. One is Tamale, another one is Wa. Both of these regions, if you see on the right side of this figure, Tamale is very prone to urban flooding. Wa is very vulnerable to flooding in general. And in both cases, we see a large proportion of semi-urban and peri-urban and rural population living in earth-based construction. However, the trend has been shifting. In Wa, we see more preference for cement-based construction. In Tamale, the situation is still very similar, predominantly because of the economic regions. So in this project, we want to find out what are the local practices to deal with the flood in earth-based construction, and what is the availability of biopolymers and bioresources which can provide resilience towards wettability in earth-based construction. Even though earth-based materials are a preferred choice of low-income groups, there are challenges with it itself. Next slide, please. If you will look at the local earth or soil availability in the region, with more and more awareness towards property rights and the rising value of lands, it's harder and harder to get the soil for construction. So you have to travel longer distances. And in some cases where you have these, regions where you can, without much of a problem, can dig for the soil, there you leave a hotspot of environmental burden due to the degradation in general. The other aspect, other than the availability of soil, next slide, please, is the perception of low-cost housing in general for earth-based construction. People will consider you are poor if you're living in one of these houses. There has been a general feeling among people, including my family, which lives in a village itself, to move into a concrete-based building because that's the sign of privilege. But there are practical challenges. One, that you can't paint these houses with ease. You have to construct them during dry season, so there are issues around that. On the other side, there are different methods of construction. So on the left side, you would see a hand-constructed earth-based building, and the other side, you would see a block-based construction. Block-based construction is faster to construct, and actually, you can do this much quickly across seasons. But then it is it actually has lesser resilience to flooding in comparison to the hand-built house, because it has much granular layers of the materials. Next, please. To improve these construction methods for resilience towards wettability and flooding, there are different methods that you could use from biological perspective. One most common and famous one is mineral precipitation, which is biocementation. Mineral transformation, it's a more expensive one. And the local and the common practice is using biopolymers, in which we are interested to investigate a lot more. These are naturally occurring polymers which provide better tensile strength and actually develop better wettability situations.
1 minute left.
Next, please. So these biopolymers, of course, they are cheap and they are natural, so there is very low cost and environmental burden on them. Next, please. You will see that in the current practices, there are materials like rice husk, dawa, there's a shea butter processing residue that are being mixed, but there is no known criteria or on their performance in the flood. That's what we're investigating. Next, please. Similar choice is Bini plant. Again, it is being used for rendering in these buildings. We don't know how the structural performance improves. So that's one of the aspects that we are investigating right now. Next, please. So this is my final slide. So we know that earth-based construction can be a good alternate and low cost and low carbon situation, but the engineering performance of these materials needs to be investigated. And these are our current steps that we are taking to ensure the engineering performance can be improved for these strategies. Thank you.
Thank you very much, everyone, for the nice presentation that we had. Now we are proceeding for questions and answers. I will request Dr. Alexandros to take over, please.
So having said that, let's see if we already have some questions. Rajendra, even if you have something to ask, please feel free to do so while I'm looking. Okay, I don't see.
One question for Jose.
Yeah, okay, please.
Yeah. Can you tell us more about this? I haven't carefully listened to you about the results. So what were your findings specifically on the research that you've made? It's very interesting, this life cycle aspect. So can you just elaborate a little bit on your results? I don't know whether Jose is still with us.
Maybe he cannot hear us?
Yeah, perhaps. So do you find any questions for our other panelists?
Yeah, if Thelma is here, Dr. Thelma. Dr. Thelma, can you hear me?
Yes, I can.
Here you are. I liked your presentation from the aspect that you show all these minerals and valuable minerals and elements that Africa is rich in. But you think when we talk about circularity, about circular economy, and about whatever the content of circular economy means, that we need to save the consumption of raw materials or virgin materials, virgin resources. I was a bit confused with the concept of your presentation. What is the message there that Africa has minerals that we can exploit further, whatever the impact this will bring, or that something else?
Of course, with the demand that with the amount of resources we will need to support the renewable energy, recycling and reuse alone will not be able to provide that resource base that we will need. So mining new minerals will also be relevant, but there is a need to actually invest in responsible mining of these minerals. So even though there is a need to look at circularity of these minerals, mining them is also important. So looking at sustainable and responsible mining of these minerals will be essential.
Yeah, I would agree with that. And I will also add that it's not only sustainable mining. Of course, it's still difficult to extract some of these elements from devices, from electronic devices, for example. It's quite difficult yet to recover such elements. So for now, the effort should be on both sides, on how we can extract this from Earth in a more sustainable way, which is what you said. But also the message will be that we should keep working on the technological advances on how we can recover such materials, such minerals, such elements from used devices, which is of course technically far more challenging at the present time.
Yes. Yes, I agree to that. Thank you.
Maybe Rajendra, Jose is here to answer the question.
Yeah, but we don't find any more questions from the audience. I hope the audience are still with us. There are 22 participants. We'll encourage them to ask questions because we've got only 10 minutes for them to answer. And in the meantime, can I ask Dr. Mohit, whether your project can be replicated in other countries? I mean, this is specific to your region, but is there any opportunity that we can replicate your projects in other, other places where flooding is prone areas?
Yes, the idea in this work is really to develop, scientific evidence for such practices. I think the challenge would be that some of the biopolymers we are using are very specific to African continent, and so from country to country, yes, then definitely there is a scope of transferring that knowledge, not just within Ghana, but to the neighboring countries as well, because these plants are available in general. And like say butter processing, it's not just in Ghana itself, it's in several countries. And so if we can provide an evidence of what level of flood resilience you can contribute at what proportion of mixing levels, which are not right now standardized, because the common knowledge is that you mix them, but at what proportion you should be mixing them, and what would be the ideal proportion, and what level of flood resilience that can produce. Those questions are hard-bound engineering questions, and that's where our team of researchers is working to produce that knowledge. But definitely it can be replicated in the neighboring regions. And even though having a better housing, having a concrete-based home or anything that people prefer should be available, and the financing mechanism should be there. But as long as there is an earth-based construction and there are people living there, our aim is to provide any help that we can to reduce the damages produced by floods in the region.
Yeah, if you allow, we can then close the session, because if there is no further question, and we had really 5 good presentations. It was really interesting, but unfortunately, with the time that slot that was available, it was very difficult for us to grasp all the 5 presentations. But indeed, these were very good research papers, and perhaps we'll wait for them for publication of these papers. You can share with us as well. You've got our email address, so we will encourage you to share among us, and then we can network even among us, and we can have more publications. And wish you all good luck, best of luck, and prosperous and good endeavor in your future prospects. That's all from me. Over to you, Alexandros.
Yeah, thank you all for being here and for attending this first session, the first parallel session of the World Resources Forum 2021. Thank you all, for all 5 of you presenters, for your excellent work and presentations, and I'm sure we will see you in the remaining days of the conference. Take care.
Thank you very much.
Thank
Bye.
you.